Are we ready to run take one? We'll just do it. Doesn't look like any more is coming. Well, you're the lucky few to come and visit this, because I should have written that in my abstract, but whenever I do something, I use different topics to show how to do really, really cool software that you can use in real life. It's just easier to do with something that is not real life, because then people start complaining about things there. So now, yesterday I was the guy between everybody and the conference dinner, and now I'm the guy between you and your flight home, or your car home, or your public transportation home. So I'll try to do my best not to bore you to death in any shape or form there. So I'm a CTO at Erlang Solutions, and I also dabble with Elixir, and we also do that at my company. And if I say something like Java is equal to paint-driven development, it's okay to tweet it, and my handle is there. And I can assure you there will be things that will be slightly offending for enterprise architects. So you're warned now. You can take your pills. So one of the things we first have to do is on how to become a Beamster. And I'd like for you to take a deep breath now and stare into the screen, and you should start thinking, I love Beam. That's the runtime that Erlang and Elixir, I love Beam. And now you relax and watch the screen for a few seconds. Just absorb it. Let it go in. I love Beam. Yeah, good. Now you're ready. Good. So the whole thing centers around the golden trinity of Erlang. And it's the same thing in Elixir. It's just something that I coined when I was preaching about Erlang. So it's about having share nothing, small little processes with message passing between them. It's also about failing fast. So if you don't know what to do, kill yourself there. So that's, and if others are misbehaving, kill them there. And in order for that to function, you need some failure handling there. So that's how the things you put together in a system in Erlang, in Elixir. What I will talk about today is more of the share nothing. How do you go about architecting things with a lot of small processes that are sending messages between one another? How do you do that? Because that's not what you're being taught in the universities there. And in order to understand the concurrency, we can talk about, and this was Bodil Stokke last week at the Erlang User Conference, Node.js has an interesting approach to concurrency by having none. And that's the kind of thing, because they, in Node, and also all the languages, there can be only one. There's one thread of execution, and that's what you have. That's not really concurrency. That's just callback hell. Beamster concurrency, meaning Erlang, Elixir, and everybody else, is that you have a ton of lightweight processes. And then, of course, it would be nice to be able to show a picture from a movie, just like with Highlander, there can be only one that explains those things, that then shows a lot of good things just magically happening. And I've searched a bit for it. I couldn't find anything. And it seems like the people writing movie plots when they, in Hollywood, they go, we want to have this good thing that keeps multiplying, and it's just good all over. It's not a good movie script for some reason in Hollywood. But what they have done, and this is where, yeah, if you feed your beam after midnight, it will multiply. And there will be more and more processes. And eventually, you'll be seeing a manager process here, supervisor, controlling things, and some others logging processes will be singing jollily around, and then you have somebody that will go around and kill and modify what's going on in your system. So that's the closest thing I come movie-wise to something where there's just a ton of them, and in our case, they're all good. They don't get nasty there. Good. Now, and then, because, as I told you earlier, I do these things so we can show things about real software engineering. So we're going to talk about methodology and technology. And right here, I've already come like 50% into a buzzword compliant talk there. And then one of the things here, and this is where everybody's sitting down. Yes, including enterprise architects, also sitting down. Good, thank you. UML is not the answer. Just, I haven't found a problem where UML is the answer yet. And given the kind of things I've seen, I do not want to see a problem where UML is the answer. And one of the things, actually Michael Jackson has something to say on this. And you'd be surprised here, but it's not that Michael Jackson, of course. It's the guy that did all sorts of things about structured programming. And he has one on software requirements and specifications. That's a book you should read. And then you should read the section on brilliance. And then you can tweet things about fight UML with that hashtag and do something there. And I'll just paraphrase the brilliance section on it there. So he used to work a lot as a consultant. He went out, he trained a company, and then the manager afterwards, he just came tagging along. What do you think about Steve? So Steve's the lead architect in that company. And Michael there's like, normally he charges extra for all these extra advice and performance reviews, but okay, he said, no, you know what? Wendy, I think Wendy was very good. And he goes, Wendy? Nah, Wendy, well, we've given her a lot of different problems, and they've all turned out to be very easy. She hasn't really proven herself. Steve, on the other hand, he produces these gigantic charts that only he can understand. He's really, really good. Think about it. So what you see in real life. No, so what you really have to do, and this is what you need to do mission-critical systems. This is how we survived when I worked at Motorola, doing mission-critical systems. In fact, anybody been in contact with the police recently? And normally that's never a question where people just go, yes, I have been. No, but they have cool police radios. It's called Tetra radios. And they also have Tetra radios here in Norway, by the way. We sold it to them when I was at Motorola. And we did a gateway to connect these systems. These are the two things you need. You don't need 10,000 pages of UML diagrams or Word documents. You don't need it. You need to have an interaction diagram that shows which things are talking to which things. And then you need to have a message diagram that shows the order of execution of things. This is the only thing that matters. Not a single class hierarchy will save you when you try to get a telecom system to work, or any system there. So then, with this protocols, that is how you solve a problem together. And that's what all software is about. Unless you can write the software on a single page, this is what you need to focus on. How do I make things work together? And of course, you can go and work for 10 years like I did at Motorola and learn it the really, really hard way there. Or you can also do a bit of cheating. So you can buy Tony Hoare's book on communicating sequential processes. And that, by the way, there are no excuses. It's available for free as a PDF online. So go read that one. It's a very good thing to explain how to think about dividing systems up and also have the focus on how do we get these different things to talk to one another. And then if you, I wouldn't say filthy rich, but it felt like that when I had to have this book at university. It costs $120. And that's US dollars, so it's the bad ones there. It was really expensive, and of course, you get that kind of book because Robin Sharp that wrote it, he was the teacher of this particular class, and that's how they make money. They write a book, and then they get Springer to put it out there. But I hung on to it afterwards, because it's golden. It uses CSP to explain how you go about solving protocol problems. It's just amazing there. So I would recommend you start with CSP, spend the $120 on principles of protocol design, and then, by the way, for this advice, you owe me 10% of any pay raise you get from now on, because these tools will make you look really, really intelligent compared to everybody around you. And they're very simple. So you can take the rest of the talk, and I'll give you some hints at it. And then, normally, when I've talked about these things, talking about protocols, MSCs, and everybody, and then people just go like this. Torben, I do not understand what you're talking about. You need to give me some examples. And then some people, the really daredevils, they say, Torben, I want to know what's in your brain. And then, word of caution here, what's in my brain is not sane. So you don't want it all out. So you need to ask specific questions there. And basically, my brain is a number of processes sending messages to one another. Oh, wait a minute. No. It's a number of neurons sending messages to one another. But it's the same model. And actually a guy called Dean Shear, he actually wrote a book about how you mimic the brain in Erlang. You can do the same thing in Elixir there. So, but that's actually quite cool there. And that's how we work. Communicate. And you can also see this thing about having processes and message passing. That's how we communicate. We walk around. We don't invoke methods on one another. We send messages to one another. Don't know where the other thing comes from. And then another thing, a little bit of a warning. I'm not perfect there. I realized that when I turned 30 there. I realized I could do errors in programming. because when I was under 30, I never did a mistake there. But I'm not perfect. So some of the stuff I'm doing here will be flawed, but I was also going to reveal to you some of the flaws I did, even trying to apply what I say and I'm preaching, and we can see what we can learn from that. So just take the journey here, and then, of course, you come up with suggestions on making things better, which I will appreciate. So the topic I'm going to talk about is Acquire, a board game made by Sid Saxon. Anybody played that? One? Only one. This is what you want to play instead of Monopoly. Monopoly is like, drawing a lottery number and see who wins. Acquire, way more intelligent. So there you have to grow and merge corporations. There you need to buy stock in these corporations, and then of course, being an American game, it's about getting the most money at the end. It's not about bankruptcy. There, it's not about being Greek in it. You need to do something else. So the board looks like this, and you will notice here the super intelligent numbering scheme they chose for this board. So they have the column number first down here, which is bizarre. You actually have the row numbers there, and they have the column number first, which is actually the worst coordinate system you can ever invent. But at least they're consistent, because the tiles you put on it use the same numbering here. Nice, sturdy plastic pieces. I got a modern version of it there. And then you also have this, which is, you see these things you put on top of the tiles. That's when you created a corporation, and then you get these little things there. That's a share in a company, and of course you want many shares so you can get many money out of it, and you have the 7 different companies here that you can create in the game. And the companies are not worth the same thing. Sorry about the quality. I only have an iPhone 4, so I have a crappy camera there. I did not say that, Apple. There. So depending on the size of the company, the shares in the company will cost and pay out a certain amount, and then there will be some stockholder bonus, which will happen when the companies are merged, or when you have the end of the game. And you can see that there are 3 different groups of companies here, and then, of course, you can mix that up. And when you put a tile, so you have 6 tiles in your hand, and you keep it secret from everybody else, because you can do lots of strategies around that. But you keep those secret, and then you put them on the board, and then there are certain outcomes that will come out of that. So the first one up here is you put it on, you can barely see the thing, but it's put on a thing where there's nothing around it. Just free, open, happy space there. So nothing comes out of that one. Then if you put something down to just next to another tile that's already on the board, then you incorporate. 2 tiles next to one another, that's a corporation. Very nice there. Then you can also put something and extend an existing company. That's the kind of thing you do if you have a lot of shares in that company. You would be very inclined to add another tile to it, because that grows the value of the company. It's almost like real life there. And then, of course, being that this is a game, and we want to fight one another in the game there, you can merge a company by putting a tile that actually connects 2 things, and this tile actually doesn't connect those 2 companies. Beautiful. Anyway, imagine that it was placed in a place where it actually connected the 2 things, so they make one thing, because they don't connect diagonally, only horizontally and vertical there. So that's kind of the rules. It's very simple there. I can even play it with my son. He's 13 there, so that's very good. And, you can also play it with people that are into finance and economy. And just brace yourself, because if you beat them, they'll come up with 100% or 1,000 excuses for why they lost. I know it. I played with my brother-in-law, and he studied finance, and both my son and him beat him. So, yeah. But we have different kinds of fun. So, a Beamster design for this. So this is how you'd go about doing it in Erlang or in Elixir there. So the basic idea would be that you create 1 process per space. So each space on the board becomes 1 process in your design. And then you take on a step further and say, I want 1 process per corporation as well. So when we form the corporation, a new process will be there for that corporation. And basically, anything you can think of, you just have another process for it. So this is what in other languages you'd throw a lot of objects after the thing. On the beam, you throw processes at the problem. That's the only difference. So that's just, and normally when you talk about processing, in other languages, people will be talking about threads, and threads are evil, hairy animals with a lot of hair between their teeth, and you don't want to touch them. Don't worry about that. Processes are nice, friendly things. They're just as nice as objects, maybe even nicer. So, and one of the things here is that these are actually microservices. All these little processes are microservices. So now I have 75% of my bullshit bingo done. There, good. Good. Now we come to one of the important slides, the design process after this. So this is where you want to get ready and take a lot of notes, or maybe not, there. The design process is this. You write up MSCs for the golden path in your code. Nothing more. This is how you design these things. And I'll take you through it step by step so you can see this. This is enough. Don't worry about all the error cases. Focus on this and we'll get somewhere. And I'll just show you the notation here. This is one way of drawing MSCs there. So you have two processes here, or two entities, and here it sends a message and it gets an asynchronous reply. And if you want a synchronous reply, I'm writing it like this, and then with a dotted line indicating that this guy over here, he's blocked until he gets this reply back there. So that's how I'm going to model everything here. And you can actually do it. It's done with a tool called Plant UML. It's not a very big font here, but it's because if I'm not making font of UML, I have a maximum size for the font I can write UML in my slides, so just to contain things there. So let's go about, let's place a tile. So here we have a player. He wants to play a tile, so he sends the message move with a given tile to the turn. So the turn is actually also a process, taking care of everything that is involved in doing one move by the player. So that's this process taking care of this. And then it asks the space where you're placing that tile on, you ask that space, what would be the outcome if I were to play this tile on you? And the space will then look around and see what its neighbors are up to there and come back with a reply there. And in this case, it has no neighbors, so the reply, yeah, nothing would come of this there. And then it replies back, the turn can reply back to the player. Now you're allowed to buy some stocks, and then the thing will be there. It will give you the choice of buying stocks in companies that are active on the board. And then you go on to do the buying stocks. And then the trick here is, with all of these things, is you want to limit the logic in each of the components. You easily go in, I'll put everything in the turn thing and have no logic in the space, or put a lot of logic into the space. So that's kind of where you need to tamper with it until you get the right feel for where you need to put the logic. But the idea is, each process deals with its own stuff, and as little possible about the overall thing. Somebody else needs to take the complicated decisions. Because that means that those things dealing with complicated things, they will have a lot of little helpers. They'll give them the information, and then they can process it there. So if you look at the board again, the first thing is we want to represent that as a number of processes, and then we spawn a process, as I said, for each little space here. There will be a process spawned in the program. And then one of the things, when you need to answer the outcome of a move, you need to know the status of your neighbors. So if I place one thing here on 5E, I need to know 5D, 6E, 5F, and 4E, how many of those are filled in order to figure out what the outcome of placing something there. I need to ask my neighbors there. And that means I need to know who my neighbors are. So when you're thinking the normal, traditional way, and this is how I started doing this until I had an epiphany there, was then you have to write something like this. And even though it's Elixir and functional programming and everything's nice and pattern matching, it's a lot of code you need to write because you have all these, the edge of the board and the corners of the board, they're nasty. Because the corners up here, they only have 2 neighbors. And then you have something where it's on the edge, they have 3 neighbors. And then down here at the very end, you have those in the middle, they have 4 neighbors. But this is how you'd write these things to be able to look up things. So, yeah, start here. And then continuing that thinking, when you then want to do the move outcome thing, So here, that's the coordinate you're trying to place something on. You first find out who are my neighbors, and for all neighbors, I ask the status of them, and the status is either it's empty, it's full, or it's incorporated, meaning that it's part of a corporation. So those are the outcomes a state space can be in. And then you say, if the neighboring station list is a list containing only of empty things of that length that the number of neighbors you had there, that's actually ugly code. Even if it's in Elixir, that's ugly code. Then you have another thing. If you have this thing where there's not a single one of those neighbors that have been incorporated already, so you're not placing something next to a corporation, then you're placing it, now that you filled out all the empty ones, then you're filling out something where you actually create a corporation, because at least one of your neighbors will then be full, but not as a company. So then you need to say, now you have to incorporate on this move. And then in all other cases, you need to see if there are anybody that's incorporated. If there are any incorporated ones in there, then you need to do a merger, otherwise nothing. This is not nice to deal with. That means you have to do something, you need to think outside the box. You all know this problem, right? You need to connect those 9 dots using 4 straight line segments without lifting the pen from the paper. And you'll see people, they'll be sitting there trying, doing all sorts of things there. But the trick is you need to think outside the box. So the first line you do like this, then you go outside. You go in, take those 2, and the 4th line, ching, you've solved the problem. So thinking outside of the box actually helps you there. And that, again, when you look at us and our representation of this board game is that here you have, it's got very nice squares on my screen, but not up here. You actually add a border around it, a number of extra fields or spaces around the original ones, because then every space inside the board will have 4 neighbors. And of course, if you're dealing with a lot of board gaming things, and programming that, you'd probably know this already, but that was something I had to think up, and I didn't realize it at first. And then you get to this, because then the neighbors here, if you have something that is inside, with coordinates inside the board itself, the neighbors are those 4 here, and some of those neighbors can be outside the board, but that doesn't matter. You still have 4 neighbors in all cases there, and in all other cases, you don't have any neighbors, because you don't want to have anything happening with those outside there. And that means that the move outcome function now becomes almost beautiful, almost beautiful. So here, you're saying if the neighbor status around the coordinate there, if it's I don't care, and then full, neighbor state, by the way, returns it sorted, empty before full, before incorporated, following that order there, then you know that, there are no corporations here, and some fields can be, spaces can be empty, but at least one is full. That means I'm generating a corporation here. So that's a simple pattern match, where I can write a pattern match based on the length of 4, because I know every space has 4 neighbors. That's nice. Then, if you have 2 incorporations going on in your neighbors, then you know that you need to do a merger, because then you're gluing together 2 corporations. And then again, it's a pattern match here, and you don't care about the rest. There could be more in it, and that's why you do a list comprehension here to make sure you get all the names of corporations in your neighbor list out. It could be up to 4. You could have a very bizarre situation where somebody has built corporations so they all join on one single space, and then you join 4 corporations. I've never played it to that situation yet. And in all other cases, which is underscore in Elixir, nothing. Nothing happens from this move. So this is as easy as this code can get there. And now we need to have an MSC, and this is my first attempt of buying stocks. So when you've done something, you placed a tile and these other things have happened, you get a chance to buy a stock. And what happens here is it's done by message passing. So the turn process will ask the player, you can now buy a stock in one of the active corporations. So it sends a list along You can choose between these, and you can buy up to 3 stocks each turn. And then the player returns a message saying, I will buy, and then you have a list of things here. And then for each corporation in that list there, you can go in, you can reserve, the bank is holding on to the stock, so you reserve a stock, you get the price and a unique reference, so you know that this is the guy holding on to this particular one, this reservation here, there. Then you check with the player's account if he has enough money to actually pay for this stock there. That's the price you came back from the bank. And then it'll return OK. Again, look at this. I'm only talking about the golden day scenario. The player's account actually works like this. If you try to debit money from the account and you don't have enough money, it'll return an error. And don't take any money out. But I'm only focusing on the golden day scenario because it's a lot more fun to talk about when things are going right than when they go wrong. And then you say, I have enough money. Then I will actually tell the bank that I'm not just reserving it, I'm actually buying it, and you pass in the unique reference you got up here, you pass it into the bank, it will reply OK here synchronously, and then you add that particular stock to the player's portfolio, so you have a portfolio of all the stocks you own in the game, and then everything's good, and then you repeat this until you've covered all the corporations there. And then at the end, you tell the player, this is what came out of buying all these. You tried to buy these things, you bought these at this price, or you get an error back on some of them there. The thing here, when I started looking at it, and this happened, and first I did, this looks nice on paper. And then I started typing it in, getting the code to work, and my fingers got slightly hot because it was painful in some way. And there was something telling me that this was not okay. And this is actually too complicated. And where it's complicated, we'll just go one back here, is that look at all this traffic between the turn and the bank. There I'm actually violating my principle about keeping the logic local to the processes there. The bank has a lot more knowledge about what goes on here, and it doesn't need to transfer it all out to the turn process. So that's something we need to fix. So this is complicated. And this one is actually better. Because in this case, buy some stocks, please. Yes, here's my choices. And then again, you have the loop here. You ask the bank about, I want to buy this one. The bank goes directly out to your account and see if you have enough money. If it's okay, it'll add it to your portfolio and say, yes, it worked. Here's the price for that one. And then you repeat this, and then you can just return that reply back there. This is a lot nicer way. And this is also one of the things, this is why MSCs are cool in communicating what it is you're doing when you're trying to get things to talk to one another. Because you put it down on paper, and you can start reasoning, and you can talk to other people about it. If you're showing them 20 pages of code, they will have no chance and say, they'll probably not, yeah, you've done a good design, yes, cool. You haven't. You need to have these things out in the open, and then you can reason about it, and you have to look at it. And then depending on your eyesight, you can hold it in the right angle and length, and then you'll find it out and say, of course, I can do this a lot simpler there. But this is a good tool to uncover these things there. Very important. Use that in whatever you do. Even if you have to do Java or C# code, use this to document what is going on. It'll make your life so much easier. Trust me on this one. There. Good. Then if you want to incorporate, then it gets a little more complicated. But then again, the rules about incorporation is actually a little more complicated. So you make a move, and you ask for the move outcome, and you have one filled neighbor, at least, but no corporations around that space there. So you tell the turn back, this would result in an incorporation on this space. Good? The turn says, okay, then it asks the corporation, is it possible for me to incorporate here? And then that actually controls the rules about incorporation, because you saw earlier there are 7 corporations in the game. You cannot create the 8th company. So if you try to play a tile that would create the 8th corporation, it's an illegal move. So you need to ask the corporation, is it okay to do this there? And then that one will return a list of corporations that are inactive that you can create at this space. And then you ask the player here, please choose one of them. Which company would you like to form today there? And then at the same time, you're telling the player's tile, he's got tiles on his hand, and that's of course again a process. You tell it, remove this tile, it's now been placed on the board, he no longer has access to this tile. And then you await, you go to a different state here, you are waiting for the player to come back to you. And this is what you would also have to do if you implemented this as a multiplayer game on a server. You'd send out something to the player, and you'd sit and wait for him to take his time to do his choice. Because he's not going to be able to do this in 30 milliseconds. Well, some players do, but they also tend to lose games. So, yeah, there you go. Then he comes back with an corporation choice here, and you go, aha! Then you take the space. Now we're incorporating with this particular company, the company name here. So this is the company we are forming, a corporation we are forming here. Then you ask the bank, will this player get a founder's stock? And that is, if there's stock left for this company, then you will get a founder's stock. So when you start a company, you get benefits. It's almost like in real life. Unless you get in bed with the wrong VCs and you get nothing. But that's a different story there. And of course, when that happens, if there's a founder's stock to be handed out, the portfolio will get that added, and then you'll be told, you're the founder of this corporation, and you got a founder's stock, and you'll inform the player, you actually founded this company, and you got a stock out of it there. And then the turn completes by doing the buy stocks that we saw earlier. So now this is covered, and we can deal with this. And then we get to, I need to drink before showing that slide. This is the hairy slide. This is the one I haven't done code for yet. This is when you want to merge things. So the beginning is okay. You do the move. You ask for the move outcome. So when there's more than one corporation in your neighbor spaces, the outcome will be a merger. And then you tell it's a merger between these corporations. Then you ask the corporation process, would this be mergeable? Because there are certain rules. If a company gets too big, it's too big to merge with other corporations. So you can't merge two big corporations. I know, maybe we should think about that in real life. If things are too big, don't merge them and make them even bigger and more fragile, but that's a different story there. Then the reply from the corporation will be, in this case it will work, there will be a surviving corporation, the biggest one will survive, the rest will be sucked into the big corporation. And by the way, if you've ever been part of a takeover, this is what happens. It's not like you're joining forces and you become friends. No, the small company becomes shuffled into the big organization. That's how it works there. Good. And then you need to do a bit of loop for all of the corporations there that are going to be merged in with the big one. You need to ask each player, his portfolio, how many stocks do you have in this company? Because the guy that has the most stock will get the majority bonus for this company that's now going defunct. This is awesome. This is how you make money in this game. Make sure that you buy stocks in little startups and have them acquired by big corporations. That's how you make money in this game. Yeah. So you calculate the bonus, and then you credit all the players their correct bonus amount. And then after that, you ask each player, what do you want to do with the stock you actually hold in this defunct company? So that's a message going on out here. You have this companies, you have this amount of stock. What you want to do it, you have three options. You can hold on to them, hoping that somebody will create the same company or corporation again later. This is where it doesn't resemble real life, but that's a tactic you can deploy in this game. You can trade them so you get, for each two stocks you hold, you can get one in the new company, the big company, because the big company is now really big, so the stock there might be really expensive. So that's one way. Or you can sell them at the current price of the company that's going defunct. And then you just repeat this until the player has taken a decision for all the stocks he owns there. And then after that, you're allowed to buy stocks there. And this, I haven't implemented this yet. So when you go to the GitHub repo, there's no code for this. There's a big comment saying to do, fix this merger thing. Should not be that difficult there. I don't think so. I need to revisit this design a little bit iteratively, because this is also one of the things you sit there and you, because there's some, when I look at this, well, let's go back here. When I look at the stuff that's going on, there's a lot of stuff going on here. And I have a feeling, I know it's not scientific, I have a feeling that I might want to spawn a process to handle this, instead of trying to let the turn deal with this. maybe it's a better idea for me to spawn a process and that process do the work and report back when it's done. But that's something I need to play a little with and have a little more time going through proper MSCs there. And of course, if some of you start looking at it and you know the game, then by the way, I can send you links to the rules in PDF if you want to have a look at it. There's something here where we can probably have fun doing this. So for now, we've actually not implemented anything. We've just written down some MSCs there. So we have an idea about how we're going to design this. Then we come to an implementation. And that's where things tend to get a little bit tricky. Because if you haven't done anything on the Beam before, either in Erlang or Elixir, all these processes and how do I structure this? So you have a number of standard behaviors you can choose from. There's something called a gen server. It's a generic server. It is truly generic. There are things called tasks. There are things called agents. And then there's a generic finite state machine, which is something you borrow from the Erlang, the underlying Erlang libraries there. And the question is what to choose. When you're looking at this, all these processes I was writing up there, which one should you choose? Because one thing is to draw a number of lines on a piece of paper and try to look intelligent and have some messages, again, just lines on a piece of paper going between them. One thing is having that, and then the next thing is I need to turn this into code. And which one should I choose there? So the design choices you have, so we have something here, it's a process, it has to do something. So there's a span between doing pure computation and pure state. And by the way, this is José Valim, the creator of Elixir, that created this slide in the first time, so I've stolen this from him. This is not in any way my intelligence showing here. Just be clear on that there. So for the pure computation, you have something called a task. That'll just to compute something on its own, in its own process, and you return your result. Good. So if you have pure computation, then that's good. If you have something that's pure state, meaning that you have something where you send it a message, it's giving you a return message or there, and it's just keeping track of some state and not doing anything more involved than these ping-pong things. Then you choose an agent. And for anything in between, you'd pick a gen server. Because then you can both do a little bit of computation, you can do a little bit of state handling, and everything will be good. So that's like the trade-offs you have there. And then, of course, you need to pick the right one. We'll see what to do about it. And then, when it gets hairy, you bring out the GenFSM. And then it starts to look scary. I tried to find the most scary thing I could find on Google Images about a state machine, because they're nice to work with when you have the right problem for it, but you should only use them for the hairy stuff. There are certain people, it's a state machine. I'll just use it. Wait for it. Wait, make sure it's the right thing. And also that's because the gen server up here, that's a nice abstraction that's in part of the Elixir standard library, and it does some things so it's nice and easy to work with, because the gen server in Erlang is quirky and you need to implement a lot of callbacks before the compiler is happy. It's not the same thing in Elixir. You've got a lot of good sensible defaults. The GenFSM, since it's coming from Erlang, it will complain like hell when you try to compile it. You must implement all these functions. If you do not even provide a stop for it, the compiler will complain. This is Erlang for you. It complains about everything there. But then again, it's for telecom, so it's okay to complain there. And then you have to add functions with the state name 2 and 3, depending on if it's a synchronous or an asynchronous event you're handling there. There are no default implementations. Basically, it's a bit of a pain. But when you need the GenFSM, you need to accept this pain. And then it almost sounds like you're doing Java and pain-driven development there, but this is tolerable pain. This is pain we can live with there, because the GenFSM abstraction is really cool there. But I want to create a better implementation abstraction of FSM. So I have some ideas brewing in my head there, and I'll try to put them together in something, and hopefully it can be accepted into the Elixir code base at some point. Also because I've worked a lot with GenFSMs in Erlang, and when you're doing telecom stuff, the abstraction is spot on. It's the best thing you can get. You live with the things because you're going to use all the callbacks and everything. It just makes sense when you do telecom. When you're doing board games, you're not doing telecom. So having to implement all these different callbacks feels kind of painful, and we don't want that. So let's go through them one by one. The player account, That's just keeping track of his cash. You start out with $6,000. You can do debit and credits on that account, and then you can show the balance and see how much money you've got at a certain point. Any takers on which behavior to choose for this? Was that an agent? Yeah. Sold! There we go. Of course it's an agent, because it's a pure state thing. You're keeping that there. And I'll show you the code. We can actually, in 2 slides, show you all the code for the agent there, which is good. I didn't even cheat with the font size here. So here's start cache, an attribute here, so we can have that under control. And you say, okay, the state here in this agent will just be the amount of money you have. And then here's a little trick. This is an important one. You name it using this function via name player. And I'll explain how that works. That is, you use a library called gproc from Erlang that allows free-form names. Because in Elixir and in Erlang, you can't just take a random name and use it to name a process. You can do that if you want to name it as a global process across a number of nodes in your system. But let's be honest here. If I'm in a board game trying to distribute the logic of a board game over several machines, it's slightly overkill. You do not want to do that. It might be great fun to do it, but I would not recommend doing that. But gproc allows for these kind of structured naming, so any term can be used. So in this case, I'll name it after the module, so that's player.account, and then the player name, which can be anything that the player chose to call himself or her. And then the via name is then part of how you name things with the OTP library, which this all originates from, via gproc, and then you need to have this funny thing written here, there. It's okay to consult the documentation on this. I do that all the time. It's really hairy, these things here, so that's why you hide them there. So that takes care of starting things, and gproc is a really cool thing to use in your projects, so go about doing that. Only recommend it. The only thing is, do not try to put 50,000 processes into it and expect it to reply really fast. I've done that, and I shouldn't have, but I solved the problem later. But yeah, and then we have the operations on the agent. So of course we have the balance, which is then just return me the amount of money you're holding. The debit there is actually what's with an agent called then get an update. So you find the name for it, and then you do a function called handle debit using the state and the amount you want to debit. And then that function is actually down here. So if you have more money in your account than what the person is trying to debit, it's okay. Then we can take that money out of the account. You can't owe anybody money in acquire there. And then you return an okay, and the new state will be the one where you've subtracted the amount from your current holdings there. And in all other cases, you return an error. You cannot debit this amount. I do not have enough money to pay this. So that's how this works. And then, of course, the credit there is with an amount here. You make sure that it's an integer there. And you also want to make sure that somebody is actually crediting money with a positive amount. I just paid you minus $400. You don't like that statement. It's just wrong. There. And then, of course, you just update the amount here, there. And then if you haven't fallen asleep after a long conference yet, you notice here, what happens if this is not true? If it's not an integer you're calling with, or if it's not an amount greater than 0, there's nothing to handle that case. And that means that the caller will die. The process calling this credit with incorrect arguments will die. And that's the way you do it on the beam. If you do something wrong, you can expect to die. And that's why we have supervisors for. It's just the way it is. And the thing is, this now, open up your nose and can you smell it? Suck it in. Real good. It's a microservice. Little contained thing solving one problem. So this is really super good. Yeah. Now, on to the next thing, the space. So that keeps track of the status of a space, so that, as I told you earlier, it can be empty, a tile can have been played on it, or it's actually incorporated and part of this corporation there. You also want to be able to show the status of of it, and then you want to determine the outcome of a move. So if somebody asks you, if I was to place a tile on you, what would happen there? So any takers on which behavior to choose for this? Gen server? Yeah. Actually, you can get away with agent. And there's nothing here except experience with these things that will make it clear that agent is enough. But I'll show you that. And this is where hope for these slides like this will actually help out. So I'll show you. So when you fill, the only thing you need to do is to return the new state here. So you do the same gproc fun stuff there. And you do a handle fill function. That's what you see a lot of times. And actually, you don't care what was in the space before there. You're hoping that people don't play the same trial twice there. Actually, they can't because there's only one of each, but there we go. So you fill it out, and then you ask the neighbor status here. If there's one of the neighbors that's incorporated already, then the only thing you need to do is you need to tell all the neighbors of this space where you're putting it down, they need to join this corporation, because that's where you're hooking in existing loose tiles to an existing corporation. So they are sucked up into the corporation, and then you tell the corporation that this cell here, this space, is joining this corporation there. And then the new state after that will be that you're incorporated, and in all other cases, then the neighbor status would have been either all empties or some that are filled there, and then after this it'll be full. So that's all good, and that's when you're filling it. So that's a simple case there. And then, actually, well, I do love that smell. So go on. And then the player, as I've talked about, he has three microservices he's consisting of there, and there will be a trick question in a few seconds. He has an account, the number of tiles he's holding on to. And what was the other thing he had? Oh, there's another one. We'll show that in a few seconds. So what abstraction to use here? Well, you can't answer it because I haven't given you a chance. The thing here is you actually want that to be a supervisor. And you want it to be a supervisor because it has underlying processes that is together builds the entire functionality of a player. So you need to have a player supervisor that will supervise all players in the game. Each player will be initially anchored by a supervisor process, and then you have the count, the number of tiles, and his portfolio, the stock he owns. And this is a very typical pattern when you're trying to do these things in Erlang and Elixir, is that you have a number of small things taking care of a little controlled job that you can understand, code you can read, and you're not cluttered about it, and then you can collect them together using supervisors there. And that actually means that when you have the player thing here, you will see that it uses the supervisor here, start the supervisor, again, name it using gproc there, join the game. When you are started as a player process, you join the game so that the game knows that you're ready to play. And then for each of your children, which are just worker processes, you put them into a list, and then you call the supervise function, and then all those processes will be kicked off and supervised by this player process. So then you have everything contained in one place, and that means if you want to kill the player at some point, you kill this supervisor thing, and it'll kill all the children automatically. So that's very nice. Everything is contained, and everything is started when you needed it. Yeah. Then there's one thing, and I haven't done that yet there. The way I've done this, I actually expose to everybody that the player consists of these three processes. And that's actually not a good software design. As I told you, I'm not perfect. I don't get things right the first time. The right thing to do, I think, here would be to put an API on what a player is into the player module. So that when I want to say I want to remove a tile, it's a function I call in the player module, which then directs it down to the underlying process. Because that means that I don't have to worry about the underlying representation of this. I could merge all these processes into one if I, if I got the idea that doing something that smells like OO is a fun thing to do, I could do that there. But I think that would be the right way forward to do this. Of course, somebody can come with a pull request if they can beat me to it there. And then the turn. The turn is actually controlling the execution of a turn from a player. And it interacts with the player regarding choices during the turn. And it can actually also interact with other players than the one placing a tile, because you saw the merger thing, then you have to ask people and all these things. So what's a good behavior for this one? This is not a trick question. There's four behaviors to choose from. Any takers? No takers? This is slightly hairy. Slightly hairy? It's actually a GenFSM. You actually need to have a GenFSM to handle this without losing your hair while trying to do it with the Gen server. And this is also one of the things. If you feel like you're so comfortable with Gen server that you're using it for everything, and I see people doing that, then they will also start implementing, and then they will have a state field in its state data for this Gen server. And then they'll change that to a new name depending on what state you're in. That's a good smell that you should probably use a GenFSM, because they were meant for this situation. So, yeah. So the turn then, actually you can break it down. So when a player tries to send you a message, a move from a certain player with a certain tile there in your idle state, the idle state of the turn, then you ask the game itself, that's another process, what's the current order of players, who's to play now? And if it's not the player placing the move, you just have, and this happened a lot for me when I was testing this out with my imaginary friends there. Bob always wanted to play before it was his turn. So you have to tell him, Bob, you cannot play right now there. So there, in that case, if it's not the correct one first, you tell the player back, not your turn. Go away. And then the next thing is you need, if that tile is one of your own tiles, so you can't just grab a tile from one of the other players and place it on the board. This normally happens when you play with small children, but if you'll see in my code base, I think Chad is trying to doing that as well, because he had a really good idea about stealing one of Amy's pieces. But yeah, go check the GitHub. It's more fun in real life if you try to steal things there, but that's a test for it there. But if in case it's okay and it's a correct tile, you handle the move in a different function. I'll show you that in 2 seconds. And in all other cases there, you tell him, incorrect tile, and then you continue to be in the idle state until the player actually figures out to say, I want to place a correct tile. So that's building in a little bit of security that people are not trying to cheat in this. And just to remind you, the move outcomes here, nothing. The first one, if you're placing them with no neighbors around. Second one is, then we'll have an incorporation here, because now you have 2 tiles being glued together. Here, actually nothing, because you're just extending a corporation. And this was the one where we actually had to have something that glued together these 2 corporations there. And then that function actually looks like this. If the move outcome, you ask the space, that's what we had the space function for there. What's the outcome of this move? If it's nothing, you fill the space with the tile, you remove it from the tiles the player is holding on to, and you tell him, now it's time to buy stocks. This is just literally translating the lines describing what happens in the game book there. Again, contact me and I'll get you the PDF with the rules there. If the space tells you, now you have to incorporate, then you ask the corporation, are there any incorporable things here on that tile? So if it's no corporation can be made, okay, you fill the tile out. That's actually a bug in this, but I will leave it to you to fix that bug for me. Then you remove the tile from the players and you tell him to buy stocks there. In case you can actually incorporate, you tell him, please choose a corporation among these inactive corporations so we can get a new corporation on the board. You remove the tile from the player's stock of tiles, and then the next state you go to, and this is where we need the GenFSM. I am now awaiting incorporation choice from this player. And then the state you're keeping is, you know which player has his turn right now, you know what tile he placed, and you know the kind of corporations that are available to choose from. So you keep that in your state data, so then when he comes back with the reply, you can use that to detect if he's done the right thing there. And then in all other cases, the last reply that can come out of space is merger, handle that. In this case, just back to idle. Good. Now, wrapping this up there, if we talk about microservices, let's focus on the protocols. People have created protocols for 40 to 50 years. They work. All this buzzword magic people are throwing around microservices, it's about encapsulation and making things that do not depend on other things. Just focus on the protocols. That's what's going to take you from being an average programmer, which none of you are, but to be rock star programmers. So focus on the protocols there and forget all these buzzwords about microservices. And if you're in an environment where it's important to talk the buzzwords, use the protocols and then translate it into microservices bullshit bingo afterwards. Then it'll work. If you want the code, it's on my GitHub repo. Warning, warning, warning. It's incomplete. It has bugs there. But it's a very friendly repo. It accepts PRs from people. And if some of you get really, really enticed about it, I'll make you collaborate on it there. So go in, have a look, and look at these things and see what's going on. And then a word here, being polyglot is actually good. So this is one of the charts you find out there showing all these wonderful languages we have today. Well, strike that. All these languages we have today and how they depend on one another. Not all of this is good. And then you have imperative, functional, object-oriented, declarative languages out here. And and you can see, that's Prolog, the only declarative language in the world. There, funny stuff. Learn you some Prolog there. That's a book that'll never be written, but never mind. Learn it anyway. The point here is, you should stay curious. If you were unfortunate to be younger than me, you would probably have been subjected to the there can be only one language thought, there can only be Java in universities. You learn one way of thinking, and that's bad. You need to learn different ways of thinking. You need to explore this map. And luckily there are lots of good resources out there you can use. Another thing here is, Erlang Elixir is not on the map. That's your number one reason for learning it. It'll teach you something different. And lo and behold, some of the things you learn from using this with Elixir and being very idiomatic about it, you can bring those things right into the stuff you're doing at work. Because trust me, you're not going to be allowed to do Erlang Elixir from day one when you say it. It takes a lot of beating by senior people before you're allowed to do something like that. And the thing is, the advice here is you need to release the Beamster inside yourself. There's a little Beamster inside of you that wants to get out. Release him or her and have fun with it. So the thinking here is that the basic concepts here, and that's what I've focused on here, processes, message passing, and the modeling, in many cases is straightforward there. We'll see with the merger if it's straightforward still there. And then just remember the golden trinity of Erlang. Same applies to Elixir. Share nothing processes with message passing, fail fast, and failure handling. I'll do some other talks on that and do some things there. And that concludes my talk. Thank you. Questions? And remember to vote on the way out.
How the Erlang Elixir processes, how do they compare with actors in Scala?
They're way better. No. It's the same abstraction. The only thing that makes them really different is due to the runtime, because each process on the Erlang on the Beam, it gets its own heap, so it's totally isolated from everything else, and that also means that when you do garbage collection, it happens only for that process. So you don't get the big garbage collector whole thing that you get on the JVM. So that's how they differ, and that's also why they are so dirt cheap, and you can have tons of them. Yeah. More questions? Yep.
It's really a Beam question, I think.
Yeah.
I'm completely new to Erlang and
Yeah.
Elixir. How portable is the VM? I mean, can I run it on like ARM-based?
Yes, you can. We've had it running on the Raspberry Pi 1, actually, and we managed to get a process ring of around 140,000 processes sending messages around. We tried to do the same thing with Java on it, and after 10,000 it threw up. It just exploded. That shows you how lightweight they are, and also the portability of it. It goes down. You need to have 32-bit processor, but just about little gumstick boards, Raspberry Pis, it runs on those things. Very portable, because the entire runtime is written in C without any real strange quirks. Yeah. Other questions? Nope. Thank you very much. Safe trip home.